Let's put together the robot base. As you're planning stuff out, we managed to put together a little module that is the mounted motor. We're going to use 4 of those. Now we need a couple of cross members. It'll have a couple of these quad blocks on each end. Those are used to assemble things. So we can just make one of them and use it twice. And then over here, we're going to use a side rail. It consists of a couple of motors. We're going to have a wheel and a shaft. We use 2 of them because it turns out they're identical. We just have to roll them around. So let's do that right now. Right now, I want to create a new assembly. Insert from our OSK23 library, or 0009 is 9 big holes and 240 millimeters long. So we're just going to pop one of those in here. And I need a couple of quad blocks. There's one, and there's one. Okay. Fasten mate, and we're going to grab the center of that hole right there, and we're going to fasten mate it up here. All right, bang, that's done. That was pretty easy. Let's go check out this other part. Grab this hole up here. Okay, and I'm going to attach it over here. Things that we have to keep our eyes open for. We may have to flip that. We saw this before. It is mostly correct, but we need to reorient the X and Y axis. So I'm going to hit the reorient secondary axis button once, twice, hit the solve button and hit the green check mark. All right, that's looking pretty good. Let's take a quick peek at inserting some screws. We need to insert 8 screws. How long do they need to be? That's a really good question. So the screw needs to go from this hole here. It's going to go up through the material, and then it's going to go up into this quad block. Well, how far is that? Here's how you can measure some stuff. This is a pretty cool thing to do. First thing I need you to do is we're going to verify the units of measurement. Each document has the ability to do that. So to change the units of measure, you're going to go up to this little menu bar that's right next to your file name. And I'm going to click up there, and I want to change workspace units. And right now it's currently set to foot, which is like a useless measurement. We're going to change it to millimeter. Okay, so see how that's been changed to millimeter? Now, ideally, I'd like to go through and change all of these things to be metric. And so we'll just go do that real quick. Newton millimeters. It doesn't really matter. The reality is that the one that you really want is the length default unit. Okay, so I've changed that to millimeter. Why is that important? Well, now I can click on a surface, say the outside edge of the side rail there, and then I can click on the inside edge. So you can see I've clicked on the top and bottom. So if you look down here, the parallel distance is 2.5 millimeters. That's the thickness of this material. That means a 2.5 millimeter screw would get me flush to the inside of this. But now I want to measure from this face up into this block. And I think I'm going to use this line right here. So I'm measuring the distance between this plane and that line. And that is also 2.5 millimeters. So that tells me that a 5 millimeter screw will get me up to this point. It turns out I can use a 6 millimeter screw. I already knew that, but I just wanted to show you that's a great way to measure things right here in the CAD program. And you can measure other things. You can measure, say, the diameter of a hole. If I come over and click on this hole and look down here, I can find that it's 14 millimeters in diameter, right? I can also measure I can click on this hole. It'll tell me that it's a 4 millimeter hole. And if I click on the one just to the right of it, it will tell me the center distance. So it's 8 millimeters on center between this hole and that hole. That's pretty convenient. And it's a nice little gadget to use. Hey, so one other thing you can do with this is I can select, let's select this hole and this hole. Center distance is 32 millimeters. There's a little measuring tape down here. And if I click on that, it'll tell me a bunch of other things, like the center distance is 32 millimeters. The maximum distance, and you can see as I hover over that, see the black line that appears over here. So watch that again. I'm going to come hover over max distance is 36 millimeters. the minimum distance. See the black line has changed and it's showing you what it's measuring. Pretty convenient, okay? We think that we need some 6mm screws. So let's go do that. I'm going to show you a new way of inserting screws. Insert standard content. We're going to use M4. We'll go ahead and stay with the button head screws. I can change their length to be 6mm. Before we inserted a screw and then made several copies of it. This is a better way of doing it, and that is you can actually select holes. I'm going to select this hole and this hole. And notice I'm just selecting the circles, and these have to be circles, by the way. And this circle and this circle. Okay, so I've selected those 4, and you can tell, take a look at my mouse there. It's telling me I've got 4 things selected. And if I just hit the insert button, what's going to happen is the tool is actually going to use those automatic mates that come on fasteners and will automatically do a fasten to mate. And if you actually look over here, you can see that it is automatically inserted 4 fasten to mates on our behalf. Okay. And you can also see over here, it also inserted the screws. So it's just a really nice, fast, and it's really honestly one of the best features in Onshape. I'm going to roll this over and I'm going to do the same thing over here. I'm going to go 1, 2, 3, 4, insert. Super useful. Look at that go. All right. Now, another thing I like to do when I do these is I actually like to right click and do a hide all mate connectors. Cleans that up. Well, there you go. We have just made a complete assembly here. So I'm going to hit the green check mark. I will point out, I'm going to do insert again, insert standard content. One thing to watch out for is if you click on a surface like that and hit insert, it's going to insert a screw in every hole. Every circle that it finds, it will insert a screw into. That's probably not what you wanted to have happen. I'm going to hit the red check mark and get rid of that. So I'm going to come down here. It says assembly 1 at the moment. I'm going to right click, rename, and we're going to call this the cross member assembly. And there you go. We have just made basically 25% of the robot base. So if you remember from our picture, the next thing we wanted to build were these sides. So that's going to use this longer rail and 2 assemblies that we've already made. We're going to come down and we are going to plus create an assembly. So we're starting a brand new assembly. And just like before, we're going to go insert from other documents, 17 hole. That's this guy here. That's 432mm. It's about 17 inches. So we're going to need one of those. The next thing that we need is we would like to insert our mounted motor bevel gear assembly. And instead of looking in our library, we're actually going to look in our current document. So I'm going to go over to current document. No part studios available. That's fine because we haven't made any yet. However, if I click on assemblies, check this out. Not only do we have a cross member assembly, but we have a mounted motor bevel gear. So you can pick one of those and a second one, and then hit the green check mark. There we go. We're starting to use our own assemblies. Pause here. Go for it. I'll wait for you. And welcome back. All right. We are going to now mount these into the inside of that rail. And if you had this stuff and had been playing with it in person, all the Go Build parts, you would inevitably have figured out, let's take a look, that we don't want the wheels to stick out beyond the end of the robot. That seemed reasonable. So the best way to do that is to use this second hole here. See the first big hole, second big hole? All right. And if I had a motor and bevel gear assembly, I would find that it needs to be offset. The front edge is going to slice down the middle of the third hole. And for that to work, we actually need to use this hole, which is the third big hole plus 1. Okay. And you would have figured that out if you had looked at like any of the other engineering diagrams or so forth. So let's go back and we're going to do that right now. So we would like to mount this motor and we're going to use the 1, 2, 3 plus 1. Okay. And that's going to be a fasten mate like you've done before. Okay. So I'm going to go pretty quick through this fasten mate. I'm going to come down here, pick one of these holes that is going to get mounted to this hole. All right. Now notice that the z-axis align properly, but I need to reorient the secondary axis to get this to line up properly. So I'm going to hit the button. That's not it. That's not it. There it is. That looks about right. Okay. I can hit the solve button to verify that's what I wanted. There it is. Green check mark. Okay. Going to do the exact same thing on the other side here. There it is. I believe I'm going to do that to this hole right here. Okay. Reorient that, solve it. Okay. There's the start of a side rail. Okay. I'm going to pause there. Go do that. Make yours look just like that. So now what I'd like to do is I know that I'm going to need screws. So I'm going to do an insert, standard content, and we are going to put the screws. So I'm going to select the holes to do that. That works out pretty good. Roll this over, do the same thing on the back side, go do that. So if we take a quick peek at our sample robot, now we need to put together this shaft assembly. And there are a couple ways to do it. One is we could actually create a shaft assembly with a wheel on it and then insert it into our part. I'm going to show you a slightly different way, which is I'm going to build one in place and then make a subassembly out of it. Here's what we're going to do. Insert other documents. Here's our library parts. For this, we need to turn on composite parts. First thing, I know that we're going to need a couple of bearings. I know that we need 6mm and 8mm bearings, so I'm just going to insert one of those. They start with 1611. The one that ends in 0006 is a 6mm, and the one that ends in 008 is the 8mm. I know that we need one of these shafts. It starts at the 2110. Pop that right over here. And there's a special washer that we're going to use. It starts with 2801 right here. Okay, I'm just going to pop that over here real quick. Then we want to insert a wheel, a mecanum wheel. So a mecanum wheel is actually an assembly. So instead of a parts here, we're going to go over here to assemblies. And there are two of them. And we'll call the one with 4 zeros in the middle, we'll call that the left-hand wheel. And the other one's the right-hand wheel. So let's take a left, hit the check mark. Go do that right now. And as always, I need to figure out how to assemble these. You can see that the 8mm bearing has a larger hole than the 6mm side. That's fine. Bearing is... I know that I want this shaft to be able to rotate on the inside of the bearing. So I'm going to select a revolute mate. So that's one of these guys. Now what's going to touch? Well, this face here is going to be what comes into contact with the bearing. And what is it actually going to touch? It's going to actually touch, well, the shaft goes through here. It's actually going to touch this thing, right? Okay. See the flange? It's backwards. So I need to flip it. There we go. You can see the shaft has gone through the bearing. That's what we wanted. All right. So I'm going to hit the solve button and hit the OK button. Let's call this the outside. So we want this, the flange of this thing to be over here through that second hole. So what's going to touch and how am I going to mate it? Well, it turns out that you don't actually want bearings to be rotating. So we can make this one fastened. See how I changed the mate's type to fastened up here? And now I'm going to go down and I'm going to figure out what is going to touch. Well, I think this surface on my bearing, which is the backside of the flange, is going to touch this side of the plate. It's going to be mated with that hole right there. Okay. And as I'm looking at it, I see that I have to flip the primary axis. There we go. So that looks about right. So now I can move the rest of the assembly, which should bring the shaft over. There we go. So that looks about right. So I'll green check mark that. I can decide that I need to do the same thing with that bearing. So I want to select this face of that bearing. And that's going to go through this hole. And again, need to flip that just because. Solve it, hit the green check mark. And in theory, if I close this, I should be able to rotate this because we put a revolute on there. See how I'm trying to move this? I'm trying to turn this, but I'm moving everything. So, hey, it's another case where I would like to come up, right click here and fix this part. And so I should be able to turn this. There we go. All right. I guess I would like to have this washer is going to fasten itself to the end of this. Okay, so I'm going to do a fastened mate on that surface in this washer. Okay, looks like I need to flip it. That looks right. I need a screw out here. So I'm going to go and find a insert standard content. I'm going to switch from a button head. I'm going to switch to a socket head screw. I want a hex socket head cap screw. It's sort of a square looking one. 6 millimeters long is fine. And I would like to attach that to this hole right there and do an insert. And there's our screw. I now want to mount this wheel to this hub. If I come down and take a look at this hub, it has this protrusion here. It's actually called a boss. That's what they call a protrusion like that. I want that protrusion to stick through this hole. See that hole up there? So that tells me I want to mate this surface, the center of this surface to, you need to scroll out a little bit, the center of this surface here. So let's do that. And it's going to be a mate because it isn't revolute because the assembly is going to revolve. So I'm going to do a fastened mate between there. See, I'm picking the surface, the circle that is on that surface. And I want to mate that to that one. All right. And of course, so I need to flip it. All right, so there it is. Hey, I need to put screws in here. It looks like we have some threaded holes here. So those are the ones I'd like to use. I don't know how long they need to be though. So let's take a look. I'm going to measure, I'm going to select that face right there. And then I'm going to roll this guy around and I'm going to select the back side of the hub. See it in there? The back side of that hub. And I can look down here and they need to be 10 millimeters long. That's how long the screws need to be. Insert. I'm going to make these 10 millimeter. I'm going to click off. I currently have two things selected that I didn't want selected. There we go. So I've clicked off. I'm still 10 millimeter screws. And so I'm going to select that hole, that hole, that hole, and that hole, and do an insert. All right. You got all that? That's a lot. But I need you to go do that now. Go figure out, go make all that work. Okay, welcome back. So at the moment we have a rotating wheel on a shaft. Perfect. If we wanted to, we could reuse this. Oh, actually, we forgot to put the bevel gear on. Oh, almost forgot a bevel gear. Let's go do that right now. Insert from other documents. Make sure that composites are on. Scroll on down here. Find the bevel gear. There it is right there, 2315. Gonna pop one of those right over here. Hit OK. Now, it turns out that the bevel gear in reality lives on this shaft and it can slide. And then what you do is you end up sliding it into place where it matches up with that other bevel gear. Then you tighten this set screw. So there isn't a fixed, there isn't anything that it rests against. It sort of hangs out on this shaft. Through experience, and this is what we're going to do right now, through experience, I have found that if I take this edge, this face of the bevel gear, and align it with this face of that bearing, it turns out that it's really close to where it actually ends up. So that's what we're going to do. All right, but we don't want it to be fastened there. We want it to be revolute there. So we're going to do a revolute mate, and we are going to pick on that face of the bearing and this face of the bevel gear, okay? And I need to flip it. We're going to call that good. Hit the green check mark. Okay, from the edge, it looks like it connects, and this is actually really close to where it really does end up. So cool. If I turn this wheel, I get a very unsatisfying spin because it's not moving the bevel gear. So what are we going to do about that? It's an opportunity to use one of the other mates. I'm going to scroll way the heck in here. Okay, I'm scrolling in here. Now, we have this flat, and that's part of this hex shaft, okay? And for the gear, we want, there's a hex shaft, there's a hex hole opening right here under this gear. See it? And so I have to kind of think about what is the normal relationship between this flat and that gear. Well, it turns out that this inside face, if it's properly on the shaft, will always be parallel to this face. So that's what we're going to do. Okay. So I'm going to scroll out here. I'm going to come over and click on nothing. And we're going to use a parallel mate. See this mate up here? Parallel mate. And it says that a parallel mate allows two entities to rotate parallel to each other and translate freely. Sounds good. Let's go have a look. So I would like to pick this flat, which is on the inside of the gear, right? See, the gear has that flat there. So I'd like to pick that flat, and I'm going to pick this face of the hex shaft. And when I do that, and then I hit solve and hit check mark, you can see that they're now parallel. So it's honoring that constraint. So that means if I turn this off, as this wheel turns, it will ensure that that constraint is always valid. And so now the wheel can turn that gear on the inside. Okay. So parallel is a great way to make sure that a hex shaft going through a hex hole always moves with it. Okay. Cool. Now, one last thing is, wouldn't it be cool if when I turn this wheel, if that wheel would turn this gear as well? I'm gonna have to figure that out. So it turns out we did a couple of revolutes, right? So there's a revolute here, and that's for this bevel gear. So I like that one. And in fact, just so I can remember it, I'm going to come down and rename this revolute. I'm going to rename it as the shaft bevel revolute. Remember how we renamed the other one? So that should give you an indication of what we're going to do. One of the things that we can, okay, so that is going to exist. We need to do, but we'd like to reuse this. We'd like to, I could come back here and do the same thing back here. But let's make a subassembly, and I'll show you how that works. We added a bunch of parts. Specifically, I believe we added a couple of bearings. There's a bearing and two bearings. And we added that shaft. See, as I'm highlighting them over here, we added that washer. We also added this wheel. We added a bunch of hex screws. There were 5 of them. There's 1 over here and 4 over there. And we added a bevel gear. Okay. See all those parts? One of the things that you can actually do is you can come over and right click on all of these. And if I look down the menu, there's a thing called Move to New Subassembly. And so we're going to do that right now. And I want you to watch what happens when I click on Move to New Subassembly. You're going to see all of those blue things over here disappear and get replaced with an assembly. Okay, here it goes. Ready? See over here? They all got replaced by Assembly 2. And if I go look in Assembly 2, it should look familiar. Those are all the parts that we just had, right? I can actually rename this assembly now. In fact, if I go back over here to our site assembly here, right? This is it's Assembly 2 is our subassembly, and here it is over here. And I can actually rename this thing. I can rename this to be, well, let's see. This is mecanum mecanum bevel on shaft left. And look what happened when I did that. This got renamed already over here. Now this whole thing still works. The relationships are all still there. Now, one of the things that when you make a subassembly is not all the relationships survived. Specifically, it turns out that the relationship between this bearing and the shaft is now broken. When you do make a subassembly, you might want to like test to make sure everything's there, because watch what happens. I can move this and I'm moving the gear and the bearing. Why is that? In the main assembly, we had a relationship between this face right here and the side rail. So there's always a little bit of something to patch up. So what we'd like to do is we'd actually like to have this bearing be re-related to this shaft, but we need it to be in a specific place. We need it, if we were to insert this as a new subassembly, we need the distance between this face and this face to be correct, okay? So what I'm going to do is I'm going to go back to assembly 1 and I'm going to look at it and I'm going to go, well, if I actually made the distance between the flanges be from here to over here, which is 48 millimeters. So if the flanges were 48 millimeters apart and this was fixed to this shaft, it all should still work, okay? So let's go back over here. So what I'm going to do is I'm going to say we would like to have a fixed relationship, fastened meet. I would like a fastened meet between this face, okay? Well, let's see what happens. Well, first of all, the bevel gear moved, and so I need to flip the axes, okay? Let's do another solve. So we're making a mess here, but we're getting closer. All right, so we now have these two bearings are opposing each other, I believe. They should be opposing each other. No, they're not opposing each other. I need to flip them again. Solve it again. Now they're opposing each other, I think. Let's see what happens. But what we need to do is we need to offset them. So this was an excuse to actually show you the offset. So an offset allows you to have a fixed mate some distance apart. And we actually want these to be 48 millimeters apart. Okay. And let me do a solve on that. Let's have a look. We went 48 millimeters the wrong way, and that happens a lot. So I'm going to come up here. I'm going to reverse that and now do a solve. Okay, so it's closer. So now we have this bearing, the center of this inside of this flange and the center of the inside of this flange are 48 millimeters apart, and they will continue to have a fixed relationship between the two, okay? And that's kind of what we want. I just wanted to point out that the offset on the z-axis, and I swear to God, every time I do this, I always have to put a negative sign. And if I start out with a negative, I'll get it backwards. So you play with it. You can do a little bit of a solve thing with it, and it should be good. So I'm gonna hit the green check mark. Can you do that? Go do that. Right click assembly 1 to rename it a side rail. I have a extra fastened mate over here I'd like to get rid of. So let's take a look at that. It's this one here. See that fastened mate? So I'm going to get rid of fastened 12. I don't need it anymore. A little complicated, but you should be able to do that. Everything working? Good. I now have an assembly that's all complete and all ready to go, but it has a left-hand wheel on it. I could actually make a new one of these and put a right-hand wheel on it. Let's do that. So one of the things you can do with an assembly is you can actually right-click it, and I can duplicate it. See that? Here goes. There's a duplicate. So this one says mecanum on shaft left, and this one is mecanum on shaft left copy. So I'm going to rename this one. I'm going to do a rename, and I'm going to go out to the end. I'm hitting the arrow keys to get myself out there, and I'm going to erase this, and I'm going to say right. I now have left and I have right. So I'm going to click on the right one. I need to swap this wheel out. Yeah, usually the easiest way to do it is to come up here and find this part and delete it. Okay. And it turns out you also want to delete these 4 screws. Okay. We'll just delete those. It's just easier to replace them. There we go. So now I'm going to do an insert. an assembly. And if you remember the left side one, we called the 4 zeros. The right one is going to be the 100 in the middle. That one right there. We'll plop this right in here. Okay. And if you'll recall, we ended up doing a fastened mate between that circle and that circle. Okay. Flip it. Solve it. That looks right. We're going to insert some screws again. Insert, standard content. And we want to find the threaded holes. There they are. 1, 2, 3, 4. All right. And then I'm going to hide my meat connectors. So now I have a left version and a right version. Go do that now. Welcome back. So, hey, side rail, insert, current document, assemblies, and you can see that we have a left and a right. And so we want to insert a right one. There it is. Okay, cool. To mate this thing, we actually only need a single mate to put this entire assembly on here. And that is going to be the inside of this flange here is going to mount to the outside of the second hole. Okay, so here we're going to do that. There's the outside of that hole. Here's the face of that flange. I'm going to solve it. We'll take a look. There we go. We now have a completed side rail. Okay, I'm going to pause here. You're going to go do that. We have one more assembly to make, which is a robot base. Hit the check mark. Create an assembly. We know that we need to insert 2 side rails, and we know we need to insert 2 cross members. So let's do that right now. Okay, insert from our current document, right? Assemblies. So we need a cross member assembly. We actually need 2 of them. So there's 1, there's 2. Now we need side rails. So there's 1, and there's 2. Do you remember our fix the part to the origin trick? Let's do that here. And so usually when I go to start, especially my main robot assembly, I like to think about where am I going to put things so that the view cube works properly. So I'd like this to be, if I click on here, I'd like to be looking down from the top. And let's look at our robot real quick. Wouldn't it be nice if I came up here and clicked on the top? I see the top, and if I can tell it, I would like to look at it from the front. And so this is sort of the front of the robot. That makes sense. And if I look from the back, that makes sense. Okay, so let's do that. So I'm going to go back over here, and I guess what I'd like to do is I would actually like to arrange for the top of this back cross member to be affixed to the origin. So that's what we're going to do. I'm going to do a fastened mate. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the 1, 2, 3, 4, 5th hole, that's this one. I'm going to select that. Okay. And I'm going to put myself in isometric mode. And I'm going to come click on the origin. Okay. So remember, it only moved the top bar. So I'm going to hit the solve button. Okay, so that's looking pretty good. I'm not done yet though, because it turns out that the top is going to work, but I would like to rotate this. So I need to do a reorient those secondary axes. So I'm going to reorient that, hit solve. So now as I'm looking at this, well, I can see the top is going to work, and I can see that the front is going to work because this will be the front. So this will actually be the back, this will be the back rail of the robot, but this seems to work. So now I should be able to click on top. Yep. And I should be able to click on front from the front of the robot. Okay. So I'm going to spin this up. This rail here, we'll pick on this rail. This needs to mount to this side rail. And I think I'm going to put the axle is going to actually go through this little hole right here. Okay. So, and it's going to be a fastened mate. So I can keep my fastened mate. I'm going to come over here, and I would like to pick side of this plane, and I'm going to hold my shift key, and I'm going to grab that center, right? So see all of the things I could potentially pick. I'm holding my shift key. I'm going to grab that point. So there's a meat connector, okay? And I would like that to be attached to, I'm gonna hold the shift key, I'm gonna attach that right here. And that seems to be about right. And I just hit the solve button to have a look. Yeah, that looks good. Now the other one, I would like to mate to this hole. Well, I guess what I need to, in my brain, realize that I need to rotate this thing around. And so let's do that. I'm gonna do this, rotate, or not rotate, but find that guy there. Now, is that what I wanted? No, I think I need to flip this. All right, well, is that what I wanted? It's getting closer, but now I need to reorient the axes. 1, 2, all right. That's looking closer. Now if I hit solve, starting to look like a robot base there, isn't it? Okay, that's what I wanted. Now I have one more cross member to put on. That's this one. Have this cross member attached to kind of in the center. In fact, I'll use this hole right here. Okay, and I'm going to mate that to, holding down my shift key, that hole there. Okay, and it looks like it's going to be backwards, so I'm going to flip it. And let's try solving it. And it's close, but as you can see, the secondary axes are not oriented properly. So I'm going to do a rotate and a solve. There we go. That looks right. Well, check that out. There is a robot base. I like it. I just realized something, that turns and that turns. That's splendid. Go see if you can assemble it and make it look like this. The beauty of doing things in subassemblies is that if you need to make a change to things, you can actually do them in one spot. So I'm going to go back over here to the side rail. And I'm going to do a special relationship. So we have this thing that spins, and we have this thing that spins. And it turns out you can actually relate the two. And how you relate the two is if you look up here on under mates, if you keep going down, there are some special things that can allow you to do a gear relation. And so this is a gear relation, okay? And so what it's looking for are revolute mates. I need to find some revolute mates. And I would like to find the mate for that bevel gear. And if you'll remember way back at the beginning, we named it. And in fact, we named it the bevel gear revolute mate. There it is right there. I need to find this revolute mate. Okay. And that is going to be on this bevel gear here. And if I come down to the mate features here, remember we renamed that too. We called that the shaft bevel. And I should be able to rotate these and see how it's working. Now I need to do the same thing on the other end because these revolutes you have to pick the specific instance of the revolute. Now I want to find this motor. There it is. And all right, so I'm going to do a gear relation on that named bevel gear revolute. Okay. I can close this up, and now I need to go find this other shaft. There it is right there. And open its mate features, and I'm going to find its shaft bevel revolute and hit OK. And look at this. Now that works. I'm going to go to our assembly, and I should be able to see that these now function. See that as the gear moves? All right, right click. Rename this robot base. Devil is always in the details because guess what we didn't do? We didn't put the screws in. Shame on me. We are missing screws. Let's go do those right now. Insert standard content. 6 millimeters is fine. So it'll be 6 millimeters long. You can do this just as fast as I can. And then I'm going to do an insert. All right. And I'm going to do that to the other side. Now, actually, there was a reason that I did it this way. We need to put some screws in, but I don't have access to the hole, right? I have access to this hole, but it's tough to get at that one that's down there. I'm going to right click, make transparent, There we go. Now I can select this hole, and I have now have access to that hole, this hole, and this hole. Now I can do an insert, but see how that making that transparent made your life easier and better. And now I can remove that. Okay. You need to go do that on the other side. Oh, well, you need to do it on both sides. Go do that right now. What did we learn today? We learned how to make some sub-assemblies. Use those sub-assemblies to limit the amount of work that you need to do. And in fact, actually, if you look at our robot base, there are some socket head button screws that are holding the assembly together. But other than that, everything else is sort of in subassembly. We learned how to use the transparency mode to help out. The last thing I'd like to show you is, you can do a little bit of organization in your document. You can see we now have a whole bunch of assemblies over here. So we have this robot base, that is sort of the main file. I usually like to keep the main file sort of off to the left, and we will eventually have another assembly called the robot, because this is just the robot base, right? One of the things I might consider doing is I might consider making myself a folder. So I'm going to make a folder here, create a folder, and I'm going to call this, well, actually I can call it robot base. I can drag and drop things like this mounted bevel gear, and I can drag it and drop it into the folder there. See that? That's one way of doing it. Another interesting way to do it is way over here on the left is the tab manager. And the tab manager, if I open that up, will show you all of your tabs, and including folders and subassemblies and part studios, right? So here you can see the two assemblies. It'll tell you they're assemblies. I've already moved those into the robot base directory. And it turns out I can drag and drop from here too. And you can see them disappear down here. So all of these parts are associated with the robot base, and including the actual robot base itself, right? So all of those are now in the robot base folder, okay? And if I want to close this, there's a little X mark up here. Create assembly, there it is. I'm going to rename this, call it the robot. Into the robot, I can actually do an insert from the current document, an assembly called the robot base. Well, robot base. The origin is on a per assembly basis. So I'm going to pull our trick again over here, and I am just going to do a fastened mate on the origin and the top of this again. Solve it. Here we're looking at it from the top. Okay, I like that. Right click my mate, fasten to origin. Go do that right now. Next steps. Next steps are we're going to do the arm next. That'll have some additional things that we'll muck around with. And once we're done with the arm, which won't actually take very long at all, we're going to start delving into part studios. So we'll be able to, I'll be showing you how to make a gripper to fit on the end of that arm. And that's where we're going. So hope you enjoyed. I will see you in the next video.